going to talk about entropy, which is the general tendency of the universe to move from a state of order to a state of disorder. I'm going to talk about entropy in relation to thermodynamics, Boltzmann's formula, and spontaneity. And I'm also going to talk about entropy in relation to the era of time and the fate of the universe. Now, this all sounds really complicated, but actually it's quite simple. The second law of thermodynamics was first formulated by Dr. Rudolf Clausius, and it summarizes two classes of process, non-spontaneous and spontaneous. This was further developed by Kelvin when he said, "No process is possible in which the sole result is the absorption of heat from a reservoir and its complete conversion into work." More simply, you need more than energy for a reaction to be spontaneous. Entropy. The Boltzmann formula is S equals K times ln W, S being the entropy, K being Boltzmann's constant, or the number 1.38065 times 10 to the negative 23rd joules per Kelvin. This allows you to calculate the average energy and therefore the average speed of gas molecules. The ln(W) is the natural log of the number of microstates, which is calculating the total number of conformations. This can be simplified through a demonstration of chess. I'm starting with one square and one piece, so I have one microstate. When I increase the number of spaces to 2 by 2, the number of microstates becomes 4. If I increase the number of pieces, the number of microstates becomes 12. The number of microstates increases exponentially. Therefore, as the number of positions increase, so do the number of microstates. If the number of chess pieces increase, the number of microstates increase as well. This can be further extrapolated for larger systems, such as the universe. A spontaneous process is a system's movement to a lower, more stable state of energy. Assuming there is no energy exchange, there must be an increase in entropy. This is supported by the second law of thermodynamics. This is not contradicted by the fact that organisms have become more ordered because the universe has become more disordered. In other words, although a small system's entropy is spontaneously decreasing, the larger system's entropy overall is spontaneously increasing. Our universe is a closed system, so we can use entropy to describe both the past and the future. As our entropy increases, so do our number of positions. Therefore, we can assume that the universe started out as an infinitesimally small spot. A point proposed by the Big Bang Theory supports this conclusion, since everything expanded outwards from one small speck of matter into a universe that is 13.8 billion light years across. We can show the number of possible microstates with a full chessboard. When only 10 moves into a game, there are over 10 to the 16th possible outcomes. Closed systems like our universe become more and more chaotic, never more and more ordered, so the entropy is always increasing. For example, if a glass of water is knocked over, the molecules of water are not going to spontaneously jump back into the glass. Because of this, we were able to develop the concept of an arrow of time, which states you can never go backwards in time, only forwards, because your entropy will never decrease. Another example can be found in a common nursery rhyme. After Humpty Dumpty falls off the wall, no one is able to put him back together again. So even all the king's horses and all the king's men cannot defy the concept of entropy.